Good morning. Welcome to science class, where we're going to talk about oceans today. Got mosquitoes this morning. My plan was to go to the ocean, record this for you, and while swimming around, holding my laptop, and it was me really great. But two things happened. One, they closed the beaches, and two, I realized that swimming with my laptop is not such a smart idea. And when you're in science class, you want to have smart ideas. No, let's jump in the ocean with our laptop. Let's go over pages 505 to 516 today, which is all about the movement of water in the ocean. How does ocean water move? First couple pages talking about waves. Waves are kind of an amazing thing because a wave in the ocean is you can actually see the force of the universe. Get all trippy with you. A wave is how we describe wave. We can do better than that. Oh, there we go. Now we got a wave. Oh, that's a wave. So a wave exists in all kinds of different places in nature. Sound waves. I'm talking to you and sound waves. Okay, I'm moving. We move. Sounds as waves. Little waves go off. You can't see them. Light is both a particle and a wave. Don't get me to that. I don't understand it. But waves are simply energy that's moving through the world. And when you're at the beach, you can see it. You can say, "Oh, that's energy moving through the earth, through the ocean." And they come crashing on the beach, and the wind has a big part to do with it, pushing the water. It mentions hurricane winds. It mentions the storm surge when the water just kind of gets even higher and it moves up onto the shores, as we all remember from a couple years ago. Go with the flow. Wow, this is like a groovy chapter. Catch a wave, go with the flow. Man, I really should have taken this to the beach and just hung out at the beach and done this. Go with the flow, man. So going in the flow. Currents. They don't have any that. The maps aren't that great on here. You can. I would say if you want to. I'll find a website for you and I'll share it with you because there's some amazing maps out there of the currents of the ocean. Because they're regular. We know what they are. It's not just water's going blah 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 blah. They're actually moving this way, and it comes up, and it comes down this way, and they make little circles. You can see our most of the currents here in Puerto Rico, they're coming from the east. They're coming from the middle Atlantic and coming down on us, and then that comes up and goes up the east coast of the United States. All the oceans have their different patterns. It's affected by whether the northern hemisphere or the southern hemisphere. But it's all pretty, we can understand it. That's one of the amazing things that science has done is we can look at how the water moves in the ocean and we can understand how it does it. It's got a picture here on page 508 of a rip current, which, as we all know, never swim in a rip current. It shows you a little picture that you can ask you to draw on the next page. It's just the same. Rip currents, avoid rip currents. They take you out to sea. There, a current that goes out from the shore into the water. You do not want to swim in one of those. You do not. Trust me. I don't know. I have friends who've been sucked by a rip current. It's not a good experience. They also show you on this map on 509, El Niño. El Niño. Nene, por favor. El Niño is when the currents get changed because of weather patterns. And this is a regular thing as well. And so there's change that's a part of the currents of the oceans don't stay the same forever. They change. And they change. And when El Niño happens, it brings big problems to South America, droughts, and And when there's a drought, which means there's no rain, it's hard to grow crops, and it causes big problems when currents change. One of the issues that we're looking at with climate change, with the way that the world is heating up, is that is going to change currents as well. And as the world gets hotter from climate change, Europe might get colder. Because if it changes, like right now, Europe, the warm water comes up from the south along America, and it comes back down into Europe. And Europe is like, yay, we get to be warmer, not so cold. But those currents might change because of the Arctic Ocean and the glaciers melting. And if that happens, it may end up making Europe colder as the rest of the world gets hotter, which they're not looking forward to. Turning the tides. We talked about this way back at the beginning of the school year when we were talking about the moon. The moon's gravity pulls the water of the oceans, and it goes in patterns. Every day there's 2 high tides, the water's high, low tides, the water's low. Here in Puerto Rico, there's not that big of a difference. You can see it. Like when I was a regular at the beach, I'd definitely see, oh, it's a low tide today. Oh, it's high tide today. There's other places where it's much more drastic. As you can see on the picture in 510, where the boats actually don't have any water. The water goes way down. Doing the math, this one I know is a little tricky. I posted somebody else's video about it, but I just want to do a real quick recap of that. What is the amount of time from one high tide to the next? Page 511. The first high tide is at 6:42 in the morning, 6:42 a.m., and it's going to get to 7:07 p.m. So that's at night, way in the morning. Okay. The way that they showed you on that video, and I like this pretty well, is first thing you're going to do is get to we want to get to 7:07. Let's just get to 7 in the morning, shall we? Here's 7 a.m. 7 a.m. How far do I have to go from 6:42 to get to 7 a.m.? Well, there's 60 minutes in an hour, so that would be 18 minutes. So I'm going to add 18 minutes. But I want to get to 7:07, not 7. So I'm going to add 7 more minutes. And so we're going to get at 7:07. So can't see that, so small. 7:07. So I'm going to add 7 more minutes. So I'm going to add 7 minutes or 25 minutes. 18 plus 7 is 25. So now I'm at 7:07 in the morning, and I need to get to 7:07 at night. How many hours is that? That's an easy jump, right? Because from 5 in the morning to 5 at night is 12 hours. Add 12 hours. Boop. 12. 12 plus 25. 12 hours plus 25 minutes is 12 hours and 25 minutes. Another way of doing this is you can change it to 24-hour time or military time. It's the other way that I know it. 8 in the morning is 8 in the morning. 2 in the afternoon is afternoon. Noon is at 12 o'clock, noon. So you'd add 12. That's 1,400 hours, as they say in the military. 14. And so so if you want to go from 8 in the morning, 8 a.m. to 2 p.m., you can. It might be simpler to change this into 24-hour time, 14. How many hours from 8 into 14? 6. It's a little tricky. It's not that big of an issue. It's one question here, so don't get bogged down on it. Don't worry about it. You can watch that other little video that I shared with you if you're interested in elapsed time. Changing shorelines. Waves and oceans current carry sand to and from away from the beach. Oh my goodness. For me, this was huge. Monday, it's almost my son's birthday. This coming Monday is my son's birthday. And last year for his birthday, we went to Ocean Park, to the beach, we sat underneath these palm trees and ran around the beach. It was great. All of a sudden last year, all those palm trees disappeared because the currents changed and it washed away all of the sand. And the beach disappeared. Like the whole beach where just a year ago we were having a birthday party, there are no trees there anymore. They all got sucked out to sea. Currents change and beaches come and go. It's back now, that beach, I'm happy to say. It's a cycle. Trees aren't there yet because they have to grow. One way of stopping that, of people trying to stop the change in the coast, is to build. You guys have been to the beach and you've seen like rocks dumped in the water. That's to stop the currents from coming in. There's a picture here on page 513 of a jetty, not a Jedi, a jetty, which is just a long stone structure to stop the water. It in the picture here in 513, it shows you it creates a little harbor, and so it's like it makes it calmer, and it makes it so it doesn't get eroded by the waves. Right. 414 through 514 through 516. You guys just filling in the answers. As you know, on page 514, the answers are written at the bottom of the page. But they're also throughout the chapter. Page 515, you guys are going to have to, what are you going to have to do? You're going to have to have more coffee is what you need to do. Unscramble the words. That's what I was. Unscramble. My brain was scrambled. The answer starts with that letter, the big letter. Abnormally high water level during a hurricane. Remember, all the answers are in the book. It's the beautiful thing about science. You read it, it tells you the answers. Unlike math, where it's like, what's 7 times 9? It doesn't tell the answers. Math tells you how to get the answers. Science books give you the answers. You read a science book, it says, these are the answers. These are the facts. And so you can find all of those in the text that you just read. Last page, 516, draw the positions of the Earth, the Sun, and the Moon during the spring tide. The spring tide is the most drastic change. The highest highs, the lowest lows. You can see a picture of that back on page 511. Circle the diagram that shows El Niño. Again, you'll find that in your chapter. Describe how a particle of water moves as energy passes through in a wave. Describe how a particle of water moves as energy passes through in a wave. As energy passes through in a wave. Wow. Let me read that one more time. I'm not reading it correctly. Describe how a particle of water moves as energy passes through in a wave. Thank you. That answer can be found way at the beginning on page 506. There's a little drawing of how energy moves in a wave in the water. Draw a diagram of the Gulf Stream. The Gulf Stream is the stream that comes up from the Caribbean, not from the edge of the Caribbean, outside the Caribbean. The near the equator, bringing warm water up along the east coast of the United States and then over to Europe. It goes down below Greenland and over Europe. So that one you have to find a map. I'm going to send a link to a nice map of that. All right, science, waves. Now I'm going to go to the beach. Ha 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 ha.